Hello students, a certain curve is such that its gradient at a point x comma y is proportional to xy. So that means we can write that dy over dx is proportional to x into y. So if we remove the proportionality sign, so we can write dy over dx as k into x into y, where k is the proportionality constant. At a point 1, 2, that means the value of x is 1 and the value of y is 2. The gradient is 4. So if I put the values over here, so that means 4 equals to k into 1 into 2. So the value of k that we got from here is 2. So our given equation becomes dy over dx equals to 2xy. So we'll put all x on one side and all y on one side. That means applying separation of variables. So that can be written as dy over y equals to 2x dx. Now, we need to integrate both the sides and at the point 1, 2. So we know that the gradient is 4. That means the point 1, 2 lies on the curve. So if I'm integrating both sides, so I got it as ln y equals to x squared plus the integral constant c. Now, we'll place the value of x as 1 and y as 2. So that means we got it as ln 2 equals to 1 plus c. So the value of c that we got is ln 2 minus 1. So that means if I just place the values over here, so I got it as ln y equals to ln x squared plus ln 2 minus 1. So if I bring all ln on one side, so we can write it as, this is not ln x, this is x squared plus ln 2 minus 1. So that becomes ln y minus ln 2, and that is equals to x squared minus 1. So that means we can write, applying the log property, ln a minus ln b is ln a over b. So y over 2, and that is equals to x squared minus 1. If I take anti-log both the sides, so y over 2 is equals to e to the power x squared minus 1, or we got the value of y as 2 e to the power x squared minus 1, and that's the required answer of the curve equation for this. Thank you, students.